transform traditional methods to create pattern blocks. So, body scanning, a new dawn, yeah? We were presented with it before, you know, it's going to offer all this potential, new ways of capturing the body, new ways of looking at the body, new ways of understanding the body. This is Thornton's book. Sorry, there we go. This is Thornton's book. It's about 1819, 1920. That's a body scanner in the top left, yeah? This is a candle and a guy and his projection on the wall, okay? And then you go through the rest of it and they're talking about the geometry and trying to work stuff out. Now, it's heavily misleading in some respects, because then they start to say we're all proportional. It's nonsense, but it does show that understanding the body in a meaningful way has been around for a long time. If you go through the book, Thornton's book, it's phenomenal the amount of information that's in there. You pick up a modern pattern cutting book, there's very little of comparison in there. Okay, so it is enabling body scanning as a technology, as an academic, as someone who's worked in pattern cutting. There's a lot you can do. I can strip data out, I can get data that I couldn't previously get. I can look at crotch curves, you know, and the depth of a crotch curve and the curvature of the body in a way I could not before. You go through the old books and you look at these harnesses they're making to try and get a measurement taken from a body, and now you've got scanning technology. And you can stand there in your underwear and you can inform people in a way you just couldn't before. So there's a really great opportunity to build some of the theory and fall back on some of that legacy that Taylor's left us. But we still have this problem, okay? So again, this is 1933, Harry Simon saying the data that the people are taking from the medical professions and from other professions are not the data we need to drive product, and we're in the same place still, okay? Because a lot of people are chasing the ISO definition, lovely, the ISO is okay, except the ISO doesn't contain information that I need to make patterns, and by that I mean, if I pick up a pattern making book, and I might be using Armstrong, Aldrich, Khalil, Tata, if you're using them from Egypt, or you know, other methods in the UK, there's a lot of different methods to pick from, probably 20 or 30. They have their own determined measurements they expect you to use, and they're not all the same. As a clear example, Armstrong, heavily used in the US, takes the bust arc at the front, right where you would take the bust, and takes the back arc of the bust at the underarm. It's like 1.5 inches higher up, right? It makes it non-comparable to all the other stuff, and it means you can't feed it with an ISO measurement. So that's a draft process you can't use. So, you know, I say it every time I meet anyone that does anything with scanning. If you don't give us the data we need for our discipline, we can't use your tech, okay? And that is the fundamental sort of truth of it. We need to embed it. To embed it, we need the information out. I'm going to probably say similar things to what earlier people have said, and what quite a few people have talked about, which is bodies are incredibly dissimilar. The mannequin on the top left, and the body form on the bottom left, okay? They're standard form. One of them's a form that's used to fit garments on, the other one's a fit model of a perceived size in the industry. And the other people are the same size as them, right? Against existing sizing theory, you're the same size if you're the same measurement, plus or minus 3 centimeters, okay? And whilst they're the same size, look at the proportional segment lengths, look at the posture, look at all the variables that are there. Okay, and that belies the sort of mythology of ready to wear and its ability to fit, but I think a lot of people have made that point before me. Okay, but new approaches to show huge potential. But what about theory and accessibility, okay, and that is important. So you've got High Stuff from 2013, really interesting piece of work, taking the scan, mapping the pattern onto it, stripping out the measurements, showing you a pair of trousers, right? It's phenomenal what they're showing they're able to do, but there's no theory to describe how they've arrived there, okay? They're not contributing to pattern theory in a way that we can start to build from. They're showing a solution, but they're not empowering anybody along the way. Huang's stuff, similar. It's great when you look into it in detail. They're saying, look, here's a method for stripping a pattern off a body directly, and you can see the shaping. Now, anyone that's cut patterns can see that the shaping for that is very non-traditional. And actually, you can see on the far right of the screen is their garment they make for that, and compare it to 2 other drafting methods. But again, it shows what scanning will allow us to do, but they're not then talking about, well, look at non-traditional shaping means. What does this mean, and what does it mean to the industry making patterns? Jamie and Kuzvichev, and again, that's a very interesting thing, looking at creating underwear. And this is just an example of one of the images from their paper. But it's really, really interesting work, looking at what a scanner can do to inform you. And there's lots of that stuff out there. But if we're really going to use scanning properly, we need to sort of understand how we're going to apply it. This is two companies, again, looking to do sort of automation, Pattern Lab, which is interesting, in the car. Both of them require you to put manual measurements online, and they then draft the patterns for you automatically. It's great, it's really empowering technology. Nobody likes drafting patterns, with a few examples of people that do. And they require sort of manual measurements to feed them. The difficulties we have within all of this is you can take a scanner and there's a big black hole of knowledge. So pattern making is practice-based, okay? You learn it, you do it, no one asks you, you don't really tell them. There isn't heavily developed theories, all right? It's really, really theory poor, yeah? And I'll pose some questions at the end to make that point. And that's not to detract from the fact that we have some phenomenally talented pattern cutters. It's just to highlight that we just don't communicate that particular bit of what I would say is engineering knowledge. So without robust theory, harnessing and gaining from technology is difficult. To some degree, almost not impossible. So we have this big gap. We've got the tech to capture the body, we've got the garments, and we've got this big hole of things we do not sufficiently know. Okay? And there are lots of those things. This is pattern making as it exists at the moment. It's fairly laborious if you go through it. There's lots of different ways of doing it, but you pick up a book, you get some paper, you draft it out. If you're good, you get on a CAD system and you draft it in CAD, okay? But it still takes a little bit of time. And most people don't enjoy it. I could probably get a student to draft a pattern in CAD in about 1 or 2 hours. But that's quite a long time if you're thinking you want to get this stuff quickly. So we've been looking at how can we do things like generating size-specific pattern blocks digitally. So this is a project that I have going with engineers, and it's quite important to work with engineers because there's a lot I don't know. I'm not a programmer, okay? If I'm not working with the engineers, they can't, and they're kind of sort of surprised at the lack of engineering knowledge. They're a little bit incredulous at the things that there's, fixed integers within a pattern making system and various other things, and little nuanced things that are done in pattern making that really should be captured properly. But we're sort of focused on enabling body data to drive pattern development. So we can use data driven from body scanning to create patterns, which I think other people have talked about. And there's real promise there doing it, and actually it's really heartening to see other people are doing it. But if you think this is new, okay, then you go to Manchester University Library and look at Patrick Turner's PhD from 1986, and he'll tell you about this automated pattern system he developed from manual measurement. And you'll never hear about it. I don't even know where it went. Okay? He did some amazing stuff, and there's some good stuff published from it, and it's gone. It just isn't there. So one of the things we're looking at that I feel is really important is addressing the theory of how a pattern relates to the body and the data required to drive that pattern. What do we need to know? And scanning gives us that opportunity to ask those questions in the way that no previous technology has. And really you just have the body, the measurement, the pattern development. That's how it exists. And another sort of important part of what we're doing is exploiting existing technology. And not only existing technology, affordable, accessible technology to revolutionise practice in a manner accessible to current skill sets. Look, if the people making patterns now can't do it and can't understand it, if they can't use technology they can afford and access, it's just never going to take off. It just will not embed itself, which is probably part of the problem of Turner stuff. Brilliant solution, just a lot of things missing, and the skill sets to sort of underpin that. And that is a fundamentally difficult thing as an educator, is the skills that we're missing within this. So, I've used scanning technology for about 10, 15 years, okay, and I've probably trained 20 people up, and only one of them works in the industry and she doesn't use scanning technology. So it's a little bit redundant. We need more people using this stuff and using it in an innovative way. It's got to be more accessible. That what we're working on with the pattern development is an open source system. So It's on there, I can share it with people, it's open source, if people contribute, it helps it to grow. Okay, there is another existing solution out there. It was really interesting to learn, and graphics have a similar solution as well, but Lectra have parametric patterns. So from a pattern cutting perspective, this is phenomenal. You can see I can knock up a pattern outline, link it to a size chart, change my size chart, change the pattern. It starts to give you that opportunity to play around with stuff, and it's good again to see there's other opportunities to do that. I could probably feed this from the scanner output. It's just electronic data, really. You know, we could just pull it in from all sorts of file types into Lectra. So Lectra have huge potential, as do other software, to embed this technology into its process. Our stuff doesn't look quite as flashy as Lectra, okay? But we're doing automated pattern creation, at least attempting to. So we're capturing data with a size stream scanner. Okay, but I'm not just capturing the data with a size stream scanner, I'm also using their custom measurement editor because there are things I want that the ISO doesn't say we need, there are things I want that traditional pattern making doesn't say we need, but I can use them. So by being able to harness the power of the scanner and being able to use this sort of custom measurement tool, I can create new data to drive the product in a different way. And I can move away from using full circumferences to using arcs, okay? Because a pattern exists at the back and the front, and if you deny the use of arcs, and there's only 2 pattern making methods I'm aware of that use arcs in their development block, everyone else has full circumference, and somewhere along the way, they got all split into an arc now, right? But you won't notice that, and you won't know about that. They're imposing a change, you know, a division. You won't know, and we can start to look at it. What does it mean? And then we end up with things like, and I think Emma touched upon it, the idea that you can draw a line straight down from the side. Actually, this line, this side seam, from the waist to the hip, pitches backwards on those people. It does not straight, even if it's straight on the pattern, it pitches backwards. So even if you try to divide a measurement on the scan, you might need to pitch it backwards for it to be right to apply in the gun. Okay, so there's a lot of things we need to start to think about. As an academic, having an opportunity to develop this software means I can start to look at those problems and see what happens when I knock out lots of data and process it. So on the right-hand side, you've got a very simple thing which is in, see, there's 2 tabs here. I've got create pattern and conduct analysis. I asked the people that developed the interface that I'm working with if they could just add a thing in so I could look at comparing 2 measurements, one against another from the scan output. And I can just direct it then and knock this out. And I get what's on the right here. And on the right is an image showing body rise, which is the height of that square. Okay, body rise is just simply your waist height to your crotch point, okay? But it's a really important measurement for trousers. And then the other measurement that represents the width of this square is hip depth, okay? So how deep you are back to front at the hip height, that might be seat. But anyway, it allows me to visually see that clustering around the shape. And you think, well, why is it important to know about the shape of that particular region? If you look at trousers, which is research I did with Alan McKinney from Iowa State University, we looked at how existing trouser patterns you might draft develop fork quantity or crotch extension, the depth between the front and back of the body. And what you discover is just one method, Beasley and Bond are explicit about it. They say the depth is 1/12 of your hip circumference, right? Armstrong's a little bit more explicit, uses arcs, and it's fairly easy to tell. The depth at the back is the hip arc plus 0.635 divided by 2, anyway, and that's how you get that extension. So you can sort of see how they're arriving at it. It's a calculation. Aldrich was harder to work out because they sort of hide it in the processing, but in essence, the crotch extension for quantity in Aldrich's method is always going to be roughly 1/6 of the hip circumference plus 1.475. The difficulty is, and I wish I had time to capture loads of screenshots of the slices of the body, people can be like wide side to side and narrow front to back, deep front to back and narrow side to side. But if they have the same hip circumference, they're going to get the same trousers. Which means the person that's deep front to back is going to be wearing trousers, they're going to be pulling out of their bum all day. Okay? And we've got to understand how that data can get in. Now, without a scanner, I'm going to struggle to get that data. And I definitely can't map the crotch curve without it being slightly uncomfortable for people and then objecting. So there's real potential to start to do interesting things with this and look at automation. I had some notes of what I was supposed to say, but I can't see them, neither can you, so. Okay, so, this is, again, why should we look at that sort of, some of the difficulties that are there. This just goes back to showing the depth. So the red line represents the depth of the body measured at the hip, okay, which would be related to the trousers. And then you can see, based upon the different methods, so I looked at 6 methods, 6 methods there, and what they would predict it to be based on the hip circumference. So these lines aren't mapping the red line, which means they're going to be different. The circumference that's predicted according to the pattern method is going to be different for all these different people. They're going to experience the trousers in a different way. But with body scanning, I could just say, well, you know what, let's use the depth to drive the pattern. And people have alluded to that. It's slightly more complex. There's other things we need to know, like how the body and pattern relate. And then, one of the things we looked at is, can we use scan data? So you've got in here, I think my colleague presented some of this last year from the research group, and we were talking about what are the measurements that are required, what's the ISO for them, can we get them out the scanner? Which is the perennial problem for me. Can I get that data out the scanner? If I can use it, and if I can use it, then we can start to look at it. What about automation? What about developing things in a new way? Scanning technology allows new insights, we can investigate new measurements, we can standardise how measurements can be taken, and we can perform repeat analysis. And we can sort of help to move things forward. That image there just shows different patterns drafted for exactly the same form. They weren't automatically drafted, I drafted them by hand, and we went through it as part of this earlier study, but it just shows how different patterns might be for the same person using different methods. But we're still left with these key questions. Okay? Is the side seam a dart? Right? So on a pair of trousers, this side seam that runs down on the skirt, is it a dart or is it a seam? You might not think that matters, but it does matter. Because a dart has particular rules about how it balances either side, whereas a seam can transgress those rules slightly more, and it can be slightly different shapes and still fit somebody properly. If you don't believe me, cut a body sample, put a princess line seam into it, and see how much different the shaping can be on the left and right. But keep it as 2 darts, and you better balance them. Okay? And then how do you define and apply arc division? Where does that side seam occur? Now I know Ashdown, Susan done some work on that, and we've looked at it in some respects, and there still isn't a clear answer, and it doesn't occur at the same points down the body. But where is that side seam? If you can't divide a circumference into arcs, then you're just denying it happens, because every pattern has a back and a front pretty much. So if someone's applying it, if it's not you, you're relying upon the pattern maker to do it. And that probably wasn't you, it's someone that wrote it however long ago, and most of them are dead or close to dead now, No one really writes pattern cutting books, and definitely not in the depth that Bray did or Thornton or any of the others. What dictates a dart suppression requirements? And I think everybody touched upon that. How do you define it? So for instance, if you look at a skirt pattern, it has a dart in the back. Most of the time, if it's got a single dart, it's the midway through the back, and it's a set length. Why is it a set length? That dart is controlling the contour between where your bum sticks out. So the bottom shape, the shape of someone's bottom, is going to determine how long that dart should be and how big it should be. So we could get that from a scanner. The scanner has all the propensity to be able to return that information to us. We can answer that question. How do you center the leg of trousers within the control section? Control section on garments are this, okay? Above the chest line, the garment hangs from that part of the body. You have 2 control sections. Above the bust, above the chest kind of thing, over the shoulders, my garment hangs from that. Lower body control section, waist to hip region, lower body garments hang from that. Okay? But in a lower body garment and a pair of trousers, your leg hangs from that. Now until I started to look at automation, and I have done pattern cutting and for a few other people, I didn't even think about this idea of centering the leg. But the leg itself is centered in the control section, okay? And it's centered relative to something in the control section. There isn't complete agreement in the methods as to what. But if you can't answer that question, if I go back to Halang and Wang stuff and that, they made a decision when they automated that pattern of where they centered the leg. There's no theory on it. No one talks about it. Thornton doesn't even mention it. I mean, historically, tailors cut individual garments for individual people, if they noticed a figure variation, they used a different draft. Okay, this is the draft for someone with bone legs. Okay, so they made those changes. Now we've standardised it, we've got these centre legs, but we can't answer that question. I'd love it if someone could say, stand up and say, you centre the legs in this way, but nobody I've met knows the answer to that question. These are fundamental questions about the theory of how we develop patterns. Scanning gives us the possibility to answer those questions, we just don't know the answer at the moment. Should these be an absolute or a percentage? I often fall out with people from the US about this. They think a percentage. I haven't seen any sort of evidence that it should be. You know, ease as an absolute, that's how I'd use it, that's how it's put forward, but maybe it should be a percentage. If you want to convince me I'm an academic, do some research, come back to some evidence, then I don't see it. But that's a major question. Should it be a percentage, should it be a fixed amount? And then how does the body directly drive pattern requirements? That's what we need to know. You know, what is it about the body that makes that requirement for that change? And you know, Emma's images do much better justice than anything I've got here in terms of showing you where you need to think about, where do I add that? How do I change that? And what is it about the body that dictates that change? So, we're going to be developing this JBot Creator software going forward. We will be looking at addressing key questions related to pattern theory. We'll be trying to explore how made to measure is accessible to the industry, especially SMEs. You know, you go to a lot of places with crafts people working, and there's usually someone in the back of that room, they've got a rail with their blocks on, and they get all these outliers coming to see instead of what the